Anyway, as of you know that we are conducting this program online talking program from October 23, and we are reaching almost 100 talks on Sundays like this. And today, of course, our guest speaker is Dr. B.S. Girish, RRI. He is Scientist G, Electronics Engineering Group, Raman Research Institute. In fact, Professor Uday Shankar has referred his name. When we contacted him, he has readily agreed to give the talk, and therefore KPA, Karnataka Physics Association, is very happy to welcome him to give his talk. And before we go for the talk, I request Professor Uday Shankar to give a brief introduction about B.S. Girish. Sir, over to you, sir.
Thank you. Thank you very much. Good morning to all my fellow members of the Karnataka Physics Teachers Association and to the students, a few of them might have joined, and of course other friends of physics who have taken initiative to be with us today. It's my privilege to introduce today's speaker, Girish. As Nagaraj sir said, he's a scientist G at the Raman Research Institute in Bangalore. He's an engineer by training, and he specializes in digital system design for astronomical signal processing. It's an area which forms the backbone of all modern multi-wavelength astronomy. Today, whether we speak of radio astronomy or space-based missions like AstroSat, Aditya L1, it is the seamless integration of science and technology that enables new discoveries in this field. Over nearly 3 decades, Girish has been at the forefront of this integration. At the Raman Research Institute, he has developed high-speed digital receivers and signal processing systems to detect very, very faint cosmic signals. His contributions span major facilities such as Giant Microwave Radio Telescope in Pune, Ooty Radio Telescope in Ooty, and other international collaborations like Murchison Wide Field Array, which is built in a very pristine radio interference-free zone in remote corners of Western Australia. He has a very wide experience of having looked at these systems. Particularly, an exciting aspect of his work lies in precision cosmology experiments, such as Saras and Pratush. These experiments attempt to detect redshift at 21 centimeter signal from neutral hydrogen, and signals carry imprints of an era when the first luminous objects in the sky were formed. Apsara is another experiment in which he has contributed extensively, and this is an experiment to detect photons emitted during the epochs of hydrogen and helium recombination in the very, very early universe. Science, especially cosmology, cannot remain confined within 4 walls of the laboratory. It demands pristine environments free from human-made radio interference. The search for such environments itself is a great adventure. It is this quest that has taken Girish to some of the remote regions of Earth, from something like 14,000 feet in Trans-Himalayan region to the Arctic, where he led India's first winter expedition in this domain. Today, we are very fortunate to hear from someone who not only builds instruments that listen to the faint whispers of the universe, but also journeys across extreme terrains to make such a listening possible. Let us now listen to Shri Girish as he shares with us his adventures, his engineering innovations, and his contributions to understanding the early universe. Over to Girish.
Professor Shankar.
Yes.
Sir, can I start, sir?
Yes, sir. You start, sir.
Professor Uday Shankar, thank you so much for the wonderful and kind introduction today. You kind of perfectly highlighted the theme of today's talk, where we are talking about carrying out precision radio astronomy experiments in remote corners of the world, especially the Arctic region. And then this has kind of helped set the stage for my talk. Thank you very much. And then before I begin, I would also like to thank Professor Nagaraju, Professor Basavaraj Kagri, and various other office bearers of Karnataka Physics Association, Nanadara, and then and once again Professor Uday Shankar for the kind introduction. I truly appreciate this opportunity, and then maybe I'll just get started. And then when you know the title of the talk, and then like Professor Uday Shankar mentioned, this is about trying to listen, trying to detect signals from the very early universe when the very first stars and galaxies started forming in the universe. Okay, so from the title, Cold Night, from the context, it is understandable because it was in the cold Arctic region. And then what I mean by ancient light will be clear in the next few slides. So I'll just get started. Like Professor Uday Shankar mentioned, this is something that in a setting like this, we thought it's always useful to recall. So scientific experiments, like I said, is not always confined to four walls of a laboratory. They're carried out in the field. And more so in the case of radio astronomy experiments, which are always more or less carried out in the field. And such field experiments take place in very challenging natural real-world settings than controlled indoor environments. So these are the pictures. What we see are some of the pictures from our various deployments, like Professor Uday Shankar alluded to. We've deployed our SARAS experiments in high altitude lakes in Ladakh, which is as high as about 5,000 meters above sea level, and sometimes in the edge of the forest in Western Ghats. And then I'll come to this. I'll have more to say about this experiment because it was we got a very important result from this experiment. So the challenging conditions here, and then recently we also had an opportunity to redeploy our SARAS receiver systems in the remote lakes of Andaman and Nicobar Islands. And then the challenge here is, in addition to the hot and humid conditions, this place was infested with venomous snakes and then giant centipedes and monitor lizards. So it was very interesting and challenging, all these places. It was really lucky to have got this opportunity to visit and carry out experiments in these places and be part of RRI's SARAS team. Okay, so this is a brief outline of my talk. So I'll begin with the evolution history of the universe, the universe through space and time, and then kind of setting the stage for what exactly we mean by ancient light. Many of you would already know this. So after that, I'll move on to some of the major activities of the CMB distortion group at RRI, of which I'm part of since its inception. And then the SARAS experiment, more about the SARAS experiment and why it is such a challenging experiment to detect the 21 centimeter faint 21 centimeter signals from early universe. And then why such SARAS experiments cannot be carried out in areas in and around Bangalore. Okay, and then why we need a remote radio quiet site, and Professor Uday Shankar referred to such a site in Western Australia, and then why we require such radio quiet observing sites for SARAS. And then I'll also briefly tell you about the background to India's first winter expedition, scientific expedition to the Arctic region, and then which led us to carrying out a radio frequency characterization of a site called Nye Olsen, which is the world's northernmost research settlement, permanent year-round research settlement in Svalbard region in the Arctic region, within the Arctic Circle. And then recently, like I mentioned, we had opportunity to deploy SARAS in Nye Olsen to carry out scientific observations. And finally, I'll conclude with a few slides on life in the world's northernmost year-round research station and how people live in such harsh and challenging environments and continue to thrive. So this is the timeline of the universe, evolution of the universe, and across space and time. After Big Bang, the universe was extremely hot and dense, and the high temperature and density kept the universe in highly ionized state, and the universe was opaque. So there was no opportunity for radiation due to very high scattering for radiation to escape and then continue forward. But as the universe expanded, the temperature and density dropped, and by about 380,000 years, the epoch of cosmological recombination occurring roughly around 380,000 years after Big Bang. This was the period when the expanding cooling universe transitioned from a hot ionized plasma into neutral atoms. Free electrons and protons combined to form hydrogen atoms, rendering the universe from then on transparent to radiation and releasing the cosmic microwave background. So photon radiation released during the transition process added to the relic radiation of the Big Bang, the cosmic microwave background CMB. And as the CMB carries the imprints of this cosmological recombination, it is a treasure house of information about the early universe, and it's an important probe in cosmology. So after recombination, the universe transitioned into dark age, where there was little or no interaction between matter and radiation, and there was no source of radiation. There were no stars and galaxies to emit radiation. About 100 million years after Big Bang, the very first structures, stars and galaxies, began developing in the universe, and ionizing radiation from them stripped electrons from neutral atoms and then began the process of ionizing the universe. These first stars and galaxies lit up the universe, what we call as cosmic dawn, and by about 1 billion years after Big Bang, the universe was completely ionized and has remained ionized since. So this is a cosmic calendar where the currently understood age of the universe, which is about 13.8 billion years, is compressed to one single year. So it is like the Big Bang took place at the beginning of January 1st at midnight, and the current moment maps to 31st December just before midnight. Like we can see here, in January we had the Big Bang, and then by end of January we had the first stars, and by May we had the Milky Way, and by September we had our solar system and Earth. And then one of the primary motivation in flashing the screen, this cosmic calendar, is to illustrate the unfathomable age of the universe and the vastness of cosmic time. So it puts into perspective the human existence and the entire, just to say that what you can see from here, the entire recorded human history just fits into the last few seconds of 31st December. So just in the about 2.5 seconds ago, Vedas were composed, and most modern history happened in the last 0.5 seconds, including world wars, first moon landing, and then the computer age. So this kind of puts human existence in perspective. That's the reason why I flashed this slide. And then the past two slides, in a way, tries to set the tone for what we exactly mean by the ancient light that we are trying to detect from very early in the universe, roughly about 400 million to few hundred million years to 1 billion years after Big Bang. So I'll now move on to the next slide, which next topic, which is activities of the CMB distortion group at RRI. The CMB distortion group is an experimental astronomy group at RRI, and our team brings together astronomers, graduate students, engineers, and project students, all of them working towards the ultimate goal of building precise spectral radiometers to detect weak spectral distortions in cosmic microwave and radio background arising from epoch of recombination all the way to epoch of reionization. So there are three experiments which are ongoing, and the first one listed here is APSARA, array of precision spectrometers for the epoch of recombination. This is to detect signals from the recombination epoch, that is when the very first atoms form. And the next experiment is SARAS, which stands for shaped antenna measurement of the background radio spectrum. This is to detect signals from cosmic dawn and epoch of reionization. And then the other one is an interesting experiment called Pratyush, which stands for probing reionization of the universe using signals from hydrogen. This is again to detect signals from cosmic dawn, where it's going to be it's planned to be a lunar mission, where a lunar orbiter, where it will be orbiting the moon and then carry out scientific observations when it is on the far side of moon, so that where we are hoping that the contaminating radio frequency interference from Earth will be blocked by moon. In addition to these three major experiments which are ongoing, one other major activity of the group is where we keep testing candidate observing sites to select locations that are relatively free of radio frequency interference, what we call as RFI for short. So to deploy our precision radiometers to carry out scientific observations to detect these weak faint signals. That is one other major activity, and this is the activity that led my visit to the Arctic in 2023 and 2024, and later with the SARAS experiment. So just to put things in perspective and where the specific experiments are taking place and which region they kind of focus on, APSARA for to detect signals from the recombination epoch. And then the Saras and Pratyush to detect signals from cosmic dawn when the first stars and galaxies form, and all the way up to the time the universe was ionized. So these are the members of the RLA CMB distortion team. And then you see Professor Uday Shankar here, Professor Uday Shankar and Professor Ravi Subramaniam. In a way, they are the OGs. They formed this group and nurtured this group, and then with all their guidance, I think that's where we are right now, trying to continue our goal of trying to detect signals from this early universe stages. Okay. So today's experiment will focus on the Saras experiment, and then I'll also tell you about the Saras radiometer, and why it is such a challenging task to detect the faint 21 centimeter signal. So about the Saras experiment, like I said, it is trying to detect signals when the very first stars and galaxies emerge. That's the cosmic dawn and subsequent reionization of the universe. And these are crucial periods in the cosmic history. Not much is known about these crucial periods of elevation of the universe due to lack of observation. We don't have much data. And one of the most important tools to study the thermal history of the universe at such high redshifts is via observations of spin-flip transition of the hydrogen atom. Since hydrogen is the most abundant element in the universe, observing this redshifted 21 centimeter, by redshifted what I mean is from the time the cosmic dawn to the present universe with the expanding universe, the 1420 megahertz signal gets redshifted to a frequency range of 40 to about 200 megahertz for the cosmic dawn and epoch of reionization. So this is the plausible evolution of the global or the all-sky 21 centimeter signal from dark ages to epoch of reionization. What we need to note here is the strength of the signal in this. It ranges from about 10 millikelvin to about 100 millikelvin, and this just goes on to show how faint the signal is and the challenges that you can expect in detecting such a signal. So what are the challenges? Like I mentioned, there's the very faint signal to measure, and then the 21 centimeter signal from cosmic dawn, as it gets redshifted as it comes reaches us. Astronomers are attempting to study this by looking back in time, and then this passes through with the cosmic microwave background as the real background, and in the presence of emissions from our galaxy, so which is about 5 to 6 orders of magnitude higher than the signal that we are trying to detect. So, and then the instrument itself has its own challenges. Ionosphere, because of the bending of signal and then distorting the signal, it brings its own challenges. But all of these can be through various with proper modeling and then design of the instrument, where all of these can be addressed. One of the elephant in the room you may consider is the radio frequency interference, which is 5 to 6 orders of magnitude stronger than the signal of interest. By radio frequency interest in this frequency range of 40 to 200 megahertz, we are referring to broadcast from FM radio, TV transmission, some satellite communications, 8-port radars communication, and some specific LANs that generate and kind of make the entire band unusable. So the requirement is a very high dynamic range, RFI tolerant receiver system, which is capable of going down to a few tens of millikelvin, hundreds of millikelvin in presence of such large foregrounds or radio frequency interference. So this is the challenge. So the scale of the problem of recovering this 21 centimeter buried in this orders of magnitude noise is, people have described it variously. I have just brought out 2 of them here. It is like finding a needle in a haystack. And the second one is measuring the weight of a bee when both the bee and an elephant are on the same scale together. So this is just to give just to pass on the enormity of the problem on hand. So what does the Saras radiometer look like? Like any radiometer, it consists of an antenna, a frequency independent antenna, a self-calibratable analog receiver, and a broadband high dynamic range RFI tolerant digital receiver, and a computer to acquire data and control the entire receiver unit. So the Saras radiometer, like I mentioned, operates in the 40 to 200 megahertz frequency range. It is split into 2 bands, low band and high band, 40 to about 100 megahertz for the low band and 100 to 200 megahertz for the high band. external and self-generated RFI add to the challenges in the system design and algorithm development. And then most of the time, the digital receiver itself is generates the self-generated RFI is a major challenge. So we house the digital receiver unit in a special enclosure called an RF shielded enclosure, so that contaminating signals from the digital receiver don't leak out from this and then reach all the way to the antenna and then be part of the receiver chain. So special precautions are taken to shield the digital receivers. And then one of the specialties of Saras is the antenna and the analog receivers are mounted on a raft, which is then floated on water, and an optical fiber carries the analog signal as RF over fiber to the show electronics, where we have analog backend receiver and the digital receiver, which generates a power spectrum and then stores it for further processing. So this is how the Saras radiometer looks like and what it consists of. So where do we stand in the global 21 centimeter experiment to detect the signals from faint signals from cosmic dawn and EOR, hypocoulic ionization? There are two experiments which are two leading experiments in this field. One is the EDGES in USA from a group of universities in USA, and the other one is Saras experiment in India. In 2018, EDGES claimed a detection of the signal where the signal's shape and stealth were very different from the way it was expected from these models which were shown here. And the community at large, they were not ready to accept this thing, and then they look forward to the Saras experiment to either say that signal is indeed like this or it is not. So a few things about Saras. It is the only operational 21 centimeter cosmology experiment in India, and it's an experiment that the only experiment that is deployed on and floated on water. It's the only experiment to have been deployed at such high altitudes. Apart from EDGES and Saras, there are many other ongoing global 21 centimeters like MIST, REACH, Rhino in the US, in the UK, Australia, and with the universities in collaboration with in the US universities. So this is where the field stands as of now. So I'll just move to the next section. That is the need for a radio quiet observing site for Saras, and why. And I already mentioned the debilitating effect very high radio frequency interference can have on the precision radiometer that we built, and then why such experiments cannot be carried out in places like Bangalore or even about 80 or 100 kilometers from Bangalore, and why we need remote radio quiet observing sites for Saras. So in the observing band of 40 to 200 megahertz, we have all these very strong interference lines like from FM radio broadcast, satellite, airport, handheld radio communication. And then in addition to this, we have some specific solar lamps, some lamps which generate unwanted emission in these frequency band and then kind of corrupt the entire band. So it's already extremely challenging to detect the weak tens to hundreds of millicuries of 21 centimeter signal in the presence of large foreground. So we would like to be away from cities like Bangalore, or even a few hundred or maybe about 200, 300 kilometers away from any place where there is civilization. And so we know we need remote observing sites for Saras. That's the reason why we need remote observing sites for Saras, so that the strong radio frequency interference in these frequencies do not contaminate and render the instrument unusable. So we need these remote sites. So I have three sites here. The first one is the Shimoga, in the district of Shimoga, where we deployed Saras. That's where we got the results when we could refute EDGES claim of a detection. And then that's when Saras 2 was deployed. We had the population density, even though we were close to the edge of a forest, population density of Shimoga district is about 200 persons per square kilometer. Whereas Professor Uday Shankar alluded to this place in Western Australia, where the world's largest low frequency radio telescope in about 50 to 350 megahertz, 400 megahertz band is coming up. That's called the square kilometer array low, where population density is 0.01 persons per square kilometer, where even if you're driving for 20, 30 kilometers, you will hardly find any human being. So we want to be far away from civilization, hoping that there is minimal radio frequency interference at the potential observing site for Saras. So we are trying to be far away from civilization. And then when we are looking for, like where we had this Saras site for Shimoga district, and then the observations were carried out just before COVID, and then we hurriedly wound up our experiments and then came back to Bangalore before Bangalore was locked down. So we carried out the observations here, which refuted Sarva's claim. But when we went back after COVID to the same site, it was a very different site RFI wise. We could not operate our instrument because of very high interference. So this also kind of very clearly tells why one of the other major, in addition to the experiments, other major activity of the group, of the CMB distortion group, is to always be looking out for radio quiet sites. That led us to this place called Svalbard in Norway, okay, which is deep inside the Arctic Circle. Again, this place has a very low population density, 0.04 persons per square kilometer, okay. So that's the reason why, that's the reason which took us to Svalbard, Norway. So what I want to convey from this slide is that just because the site is remote, it is sometimes the radio frequency characterization can throw surprises. What I mean by that is, this is a site about 35 kilometers from Port Blair in Andaman. Okay, we thought the site was really remote, and then before dusk, by the time we set up the instrument, we found that the spectrum was relatively clean. There were a couple of FM signals from Port Blair, and then other signals from satellite and other things. Otherwise, the band was relatively clean, but things changed dramatically once this light came up, and by the time it was about 6 o'clock or 6:30, it corrupted the entire band and rendered the full band usable. Like what you see here in this red thing here, it says ADC overrange. Even the spectrum analyzer found that it is very high, signal strength of the signal is very high, and it could not operate, and we had to take precautions to make sure that you are within the operating limits of the spectrum analyzer. So what I want to convey is, even if a potential observing site is remote, its RFA characterization can throw surprises. So what that means is, thorough radio frequency characterization of a potential remote observing site is a must. How we do that? We ship our RFA recording equipment to the remote region, consisting of antennas, amplifiers, and a spectrum/network analyzer and a data recording computer. We deploy them in remote areas. This is a picture from a remote place in North Andamans inside a forest. And then, as you see here, this is ranging from 5 megahertz to 500 megahertz. The 40 or 50 megahertz to 200 megahertz that we are interested for Saras is extremely clean and a very nice, except for this signal here, which is from Orcom satellite, and then there's no way to escape from there because it's a constellation of satellites. The nice thing about that is they come and go when they're within your beam. You can see the signal at this level, and then it goes away once the satellite is out of the it has moved beyond your area. So this is a very nice picture or example of a very pristine site. But the problem with this site was the Andaman and Nicobar Islands receive both southwest monsoon and northeast monsoon. There's a very small window of opportunity to deploy Saras, and that too subject to weather conditions. You can always suddenly have cyclones, given that it's a group of islands. So weather can change drastically and dramatically. It can be nice in the morning, and then by evening it can start raining, and then it is very difficult to plan a Saras deployment here. Okay. So that led us to the Svalbard, the site in Svalbard to do a radio frequency characterization. I'll just give a background to India's first winter scientific expedition to the Arctic. The National Center for Polar and Ocean Research, NCPOR, Goa, is a nodal agency which takes care of research in the polar regions, both Arctic and Antarctic, in India. Towards the end of 2023, there was a call for proposals from NCPOR for the first ever winter Arctic expedition. NCPOR received about 41 proposals. On behalf of the Saras team, there was a proposal titled Characterization of Radio Frequency Environment for Cosmology Experiments, which we submitted. And in October 2023, we successfully defended our proposal, and NCPOR, the review committee, shortlisted 15 out of 41 proposals that they received. And in early December 2023, NCPOR conveyed to us that the first expedition will happen as early as middle of December of 2023. So just to some more background about this, India has been operating its research station in the Arctic called Himadri, and till December of 2023, it was only operational during summertime, that is polar days, and in polar nights, that's the winters, it was not operational. Only some experiments which would record data, and then they were streaming data back to India. So there were no field experiments and personnel who would go there during winter or polar nights, and then India was trying to get that going and have a year-round presence in Arctic. So that's the background to the first winter Arctic expedition. So the first expedition was flagged off on 18th December 2023 by the then Honorable Minister for Earth Sciences, Kiran Rijiju in New Delhi, and a four-member team left for New Delhi. They left New Delhi for Nye Olsen. Place is called Nye Olsen in Svalbard on 19th December. And then they are the 1, 2, and 3. These were the other members of the team. And yours truly, like Professor Udashankar mentioned, I had the honor of leading this experiment to the Arctic. And I met these 3 people only in New Delhi. And then I was prepared to live and work with strangers in challenging polar night conditions of the Arctic. There were 2 students, PhD students, one from Indian Institute of Technology Mandi, other from NCPOR Goa. They were trying to carry out experiments to study climate changes, and the senior project associate from Indian Institute of Tropical Meteorology, Pune, was trying to study atmospheric sciences, changes in atmospheric sciences over the Arctic. And then obviously I was, as part of, under the space sciences experiment, I was trying to carry out a radio frequency characterization of the Nye Olsen site and to see if it is suitable for Saras deployment. That was the goal. So with this background, so our destination is Nye Olsen in Svalbard archipelago, obviously pretty far from India. So I had to take about, change about 5 flights, 5 plus 1, if you include Bangalore, New Delhi. So about 6 flights, and over 3 days, it required 3 days to reach this place called Nye Olsen in the Svalbard archipelago. Svalbard is governed by Norway, but it is out of Schengen area. So when you are exiting this place called Tromsø, you need to get your passport stamped saying that you are exiting Schengen area, and on the way back, again you need to get it stamped saying that you have re-entered Schengen area. So the reason why I'm showing you this is I have an interesting slide later on. So the destination is Nye Olsen in Svalbard. Capital of Svalbard is Longyearbyen. Okay, and I have some interesting facts to share with you about Svalbard. The Svalbard Treaty of 1920 recognizes Norwegian sovereignty over this group of islands. Nye Olsen is the world's northernmost year-round or permanent research settlements. So it operates round the year. There are more polar bears than people here. There's an estimation. Due to harsh conditions, there are no tall trees or shrubs. There are no plants which are taller than 10 centimeters. For those of us who like to have cats as pets, it is a bit disappointing. Cats are banned in Svalbard, and interestingly, it is illegal to die in Svalbard, and giving birth in Svalbard is discouraged due to lack of medical facilities. So the civil polar night. By polar night, what we mean is the sun's disk is never above the horizon from middle of November to end of January. The opposite of polar night is polar day, and we all know Norway is also called the land of midnight sun. Sun doesn't set for about 4 months from April to August. Okay. So when we are still in Longyearbyen and we are ready to make the last hop from Longyearbyen to Nye Olsen, there is a very interesting building in Longyearbyen. It is called the Svalbard Global Seed Vault, also called the Doomsday Vault. It contains billions of seeds which are stored as complete backup of Earth food crops in case there is an equipment mismanaged accident or war or sabotage of diseases or natural disasters. If we were to lose all our seeds and crops and other things, we always have a complete backup of Earth's food crops in this building. And this kind of given its special lighting arrangements, and I think it's on a hilltop, and it kind of announces when you're in Longyearbyen saying that, hey, I'm here, look at me. So you're not allowed to enter this place because of the special conditions in which all the seats, millions of seats are stored. They are maintained at minus 18 degrees Celsius, which is the recommended temperature to preserve the seats. So people are not allowed except the servicing person. Nobody else is allowed inside. So if this was about the global seed vault in Svalbard, India has its own seed vault in a place called Changla in Ladakh, and it was built in 2010. And then India joined this Svalbard Global Seed Vault in 2014, and then we have some of the seeds belonging to India kept there. So this is the last hop from Longyearbyen to Nai Onsen. Nai Onsen is a small place, very small settlement of about 2 square kilometers. The airport is very small and the runway is very small. Commercial flights can't operate. So this last hop is carried out using this chartered flight, a Dornier 228 aircraft which can carry about 12 to 14 people and our equipment. So we are in Nai Onsen. So I mentioned about the place called Tromso. When we arrived for the passport stamping, there was twilight. And by the time we left Tromso, just keep an eye on the timing here. It is on 20th December and it is mid-afternoon, 2 o'clock. And then it already at 2 o'clock, you can see that the artificial lights are completely taken over and it is dark outside. And by the time on 21st of December, around 4:30, when I reached Nai Onsen, it was pitch dark, but for natural lights, there was darkness everywhere. So the last time I saw sun was mostly in Oslo, and for about 28 days, there was no sunlight. I did not see sun for about 28 days. So that was a very special experience. So why do we have this polar night? So we all know that Earth's axis is tilted by about 23.5 degrees, and during winter season, the tilt is away from the sun, and this ensures that the sun rays don't reach deep inside the Arctic Circle, and there is 24/7 light for about 3 to 4 months in what is called as a polar night. So we have reached Nai Onsen. The aim is to carry out a radio frequency characterization of the site to see its suitability to deploy SARAS, and it was challenging polar night conditions, and we were about 1,200 kilometers away from North Pole, and this is how the Nai Onsen town area looks like during summers. It's a very small town, like I said, 2 square kilometers, and the place we were allotted to carry out our experiment was a place called Gruebada Lab, which is about 1.25 kilometers from the town, out of the town. And what you see here in this red block here, it is special, and then you have these boards called where it is cautioning you to stop here, and then you're not allowed to go out of this town area without carrying a firearm, a rifle, for example, or a flare gun. This is to protect yourself from possible polar bear attack. So when you're about to exit this safe area of the town area, you are supposed to load your firearm, and when you're coming back, you're supposed to unload your firearm, and this has to be very strictly followed. So this is how this Gruevarda Observatory looked when I went there in December of 2023, and this is how it looked when I was there in just about a month back, during where there was some light, so that I could see how I could get to see how it looks during slightly better times. So RFI antenna was installed on top of this laboratory here, and the RFI data recording system was below this fourth room here. Okay, that's how it was installed. I just have and then what was the weather conditions like? Average outdoor temperature was about -10 degrees. It was polar night. There was no sun. And then average wind speed was about 15 kilometers per hour. Because of this, the wind chill temperature or the field slack temperature was average temperature was over minus 20 degrees Celsius, and on January 4th, it was a very cold day. The wind chill temperature went down to minus 41 degrees Celsius. Okay. Life goes on. You have very limited time in the place, about 25 days to complete your experiment. So you go ahead and prepare yourself and go on to continue to carry out your experiment. So this is the condition in which we install the antennas. So what I would like to highlight is you can see that but for the light from headlamp, you can see in the background it is pitch dark. So there were some personnel from New Olsen who helped install this. Yes, this is some friend telling me to be careful because it's very slippery on the rooftop there. And then antenna was installed, and the front-end receiver unit kept below the antenna was also installed, and the output was carried to the data recording system through this coaxial cable, which is being lowered down so that you can enter the room below. So the RFA recording system was in place. So what is shown here
Girish,
is
can I request you, Girish, can you hear me?
Yes,
Yeah, just
yes.
we can request Mr. Nataraju. I think your mic is on and there is a noise coming from your laptop. May I request you to kindly switch off your microphone, Nataraju, sir?
Yes.
In the Zoom, there will be a microphone audio. You can click on it. It will disconnect the whole thing, sir. Thank you. Sorry, Girish.
No issues.
ಎಷ್ಟೊತ್ತು ಹೊರಡೋದು ಮೊಬೈಲ್ ಚಾರ್ಜ್ ಹಾಕೊಂಡು ಹುಡುಕ್ತಿದ್ದೀನಿ ಸಿಕ್ಕಿಲ್ಲ ಎಲ್ಲಿಗೆ ಎಷ್ಟೊತ್ತು ಹೊರಡೋದು
12:30
ಮ್ಯೂಟ್ ಮಾಡಿ ನಟರಾಜ್ ಅವರು ಮ್ಯೂಟ್ ಮಾಡ್ಕೋಬೇಕು ಅವರು ಆನ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ದಾರೆ ನೋಡಿ ಮ್ಯೂಟ್ ಮಾಡಿಲ್ಲ ನಟರಾಜ್ ಎಸ್ಕೆ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಅವ್ರ ಕಡೆ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಆಗ್ತಾ ಇದೆ ಮ್ಯೂಟ್ ಮಾಡೋಕೆ ಹೇಳಿ ನಟರಾಜ್ ಎಸ್ಕೆ ಪ್ಲೀಸ್ ಮ್ಯೂಟ್ ಓಕೆ ನಾವು ಪ್ರೊಸೀಡ್ ಹಿ ಹಸ್ ಮ್ಯೂಟೆಡ್ ಓಕೆ
ಥ್ಯಾಂಕ್ ಯು
ನಟರಾಜ್ ಅವ್ರದ್ದು ಮ್ಯೂಟ್ ಆಗಿದೆ ಓಕೆ ಸರ್ ಐ ಥಿಂಕ್
Okay, thank you. This is what we found. This is a waterfall plot from the data which was acquired after we set up the RFA recording system. What you see here is there were a couple of FM radio signals in that remote place as well, and there is some radio frequency interference which is intermittent from the aerodrome, the flight info services. Whenever whenever the airport came alive, only twice in a week, Mondays and Thursdays, flights come in and then take off. So that was not a big issue. One other challenge was handheld radio communication. So you're always required to carry a walkie-talkie whenever you're going out of the town area for safety purpose, so that you can contact certain people in case of emergency. So but for this, the frequency range 100 to 200 megahertz was found to be pretty good. RFI occupancy plot, you can see the 100 to 200 megahertz, except for this handheld radio communication, which more or less by night time it will reduce drastically. Okay, but for this 100 to 200 megahertz band was found to be very clean. And then we thought it was suitable for us to deploy our SARAS experiment. And then just for comparison, this is the RFI occupancy plot in the North Andaman site. And then except for the 137 megahertz Ofcom satellite, there's hardly any interference. This is a very good site, but this is reasonably good, and which is still it is worth deploying SARAS experiment there. So with this information, okay. So we have always been talking about why we need to be far away from civilization. This is a site in Gauri. From Gauri, this is a waterfall plot in the frequency range about 5 to 500 megahertz. the site called from about 80 kilometers from north of Bangalore, RRI's Gauribindur field station. You can see the number of interference lines, and then they are pretty strong. So compared to that, these two sites were quite good and encouraging for Saras experiment. So obviously the weather was very challenging. It was cold and dark, pitch dark when we were carrying out all these experiments. So darkness isn't always the absence of light, especially at such high altitudes. Nature has its own way of surprising you despite the harsh conditions. By this, what I mean is, we got to see this enchanting views of northern lights, aurora borealis from Nyolsen, some beautiful twilight blue hour pictures of the Nyolsen settlement. And then this is a picture of Himadri. This is India's research station in the Arctic. And then you can see northern lights, auroras over Himadri and Nyolsen. And then as you move away from the settlement, as you walk or move towards the Grove Weather Lab, which is about 1.25 kilometers from the settlement, the lights appear much more brighter. These wonderful curtains hanging from the sky and fluttering. This is a sight to behold. And then I think you can only, very difficult to express, one has to experience this. It is a wonderful sight, and then it was amazing experience to watch them almost every day. So we were all set to deploy Saras experiment for scientific observations in Nyolsen. A 3-member Saras team traveled to Nyolsen from 6th February, just recently, 6th February to 27th February 2026. Again, we went through the usual NCPOR process, and then the plan was to deploy Saras, and then we were back in Svalbard, which is the kingdom of the polar bear. So the 3-member team, yours truly, Saurabh and Yash, and this place, when compared to my previous visit, was slightly different. We were coming out of polar night slowly, and there was few hours of twilight every day, because of which I could see Himadri in some light. And then I could also see the settlements. This is the view from the Grove Weather Observatory. And then Norway is famous for its fjords and the glaciers. It was a beautiful sight and a fantastic setting. So how was the weather like during the second trip? Well, the previous time it was average temperature, outside temperature was about 10 degrees. This time it was a bit colder. It's about minus 13 degrees. Last time average wind chill temperature was minus 20. This time it was minus 22. But the most important thing is the lowest temperature did not cross minus 30 degrees this time. So to that extent, it was better, but there was a lot of wind this time. I have a video to show you this, the kind of conditions that we had to deploy our analog receiver out in the field. So despite this dark and cold conditions, we were preparing for Saras deployment. These boxes could not enter the door through the door of the Grove Weather Observatory. So we were forced to open the box outside and then carry the instruments inside. And we were working with the constant, although the smiles here is only for the cameras, there was always the constant fear of a lurking polar bear. Thanks to Sarabjit Singh, our station leader, who is also authorized to carry a gun, carry this rifle. So we had full trust in him, on his abilities to keep an eye open for polar bears, if any, and then we trusted his shooting skills. Okay, so in these conditions, whenever about 4 hours every day, there was some kind of light. Antenna and analog receiver on a raft, they were deployed about 100 meters behind Grove Weather Lab, and this is the lab where the backend and digital equipment, digital receiver was placed inside the lab. Again, an optical fiber carried RF over fiber and then brought it to backend analog electronics, and then the RF signals were interfaced with the correlator for digitization and carrying out cross correlation of the signals and generate cross power spectrum. So we were all ready to begin experiment next day, and then as luck would have it, an Arctic fox chewed our optical fiber cable and damaged it. This is a multi-core cable containing 8 cores and carrying signals back and forth between analog receiver and digital backend. So you can see the tooth marks incision on the fiber here, okay, and then maybe one specific canine or something like that has damaged five out of 8 cores of the cable, and because only 3 of them were functional, and then we required a minimum of 5 to operate the Saras receiver in its optimum configuration. So we had to bring back the equipment back to the lab and then reconfigure it so that we could survive with just 3 out of 5 control lines. So it was a sad moment, but that's how it is. So we brought the receiver back to the Guruvada laboratory and then did all this reconfiguration. And by the time we were ready to redeploy it, and then as weather played prompt, and then it was a bit challenging conditions to deploy that, and then weather prediction was not great, and it was going to be blizzard-like conditions for about 2 to 3 days, and this is how it was. Very low visibility, and then high speed winds close to 70 to 75 kilometers per hour. And then there was no point waiting for that because the next couple of days prediction was bad or same as this. And because of our return trip and everything is pre-decided, tickets are booked, everything is decided, so that we were getting close to our return date. So we had no other option but to redeploy the system after reconfiguration, even in this harsh blizzard-like conditions. So despite all these challenges, we managed to collect about 40 hours of data. So we could not, like I mentioned, we could not operate it in the full receiver configuration because of lack of additional control lines. So we managed to collect about 40 hours of data, and then which is being analyzed right now. And this is how the Guruvada Observatory looks like. And then I'm just walking here to the rooftop just to give you a panoramic view of the surrounding around Guruvada, and just to give you a feel for where we have installed our antennas, and we have installed our antenna and analog receiver, and then the wonderful surroundings of Nelson settlement. There are many other, like you see, there are many other experiments ongoing related to climate change studies and electrical activities over the Arctic region. And there was a lot of snow on and ice, very slippery, as you would expect on the rooftop. So just walking very carefully. And so this is where the antenna is, antenna and analog receiver, and then the fiber comes through this conduits and then enters the Guruvada receiver room in the Guruvada lab. And then now I give you a panoramic view from Guruvada rooftop. And then this is the east. As we were slowly moving towards polar day, for a few hours, like I mentioned, there is a bit of light. This is the New Olsen settlement. There is an observatory on this top of this hill here, where they are carrying out climate changes, Arctic climate change study. Okay. So this is how the place looks, beautiful. Obvious. I mean, of course, it is pretty cold, and then you need to be ready to carry out your work in these cold conditions. So this is about the radio frequency characterization and the Saras experiment in the New Olsen site. I'll conclude, go to the last section, which is about life in the world's northernmost year-round research station. they say that when you're, obviously we were aware of this, and then we had a lot of experience traveling to Ladakh and deploying our experiments. So in a way, we were physically and mentally prepared and conditioned for the harsh conditions in Arctic. So they say you dress like an onion with multiple layers. You have a base layer of special merino wool, followed by a middle layer which is of fleece, and then the outer layer which is a windproof, waterproof, and snowproof jacket and trousers, and with special boots so that the cold doesn't transfer onto your legs. So polar nights don't deter outdoor activities. Obviously, we need all our experiments and deployment and other things is outdoor activity. You can't complain. There's a popular saying in the Scandinavian countries that there is no such thing as bad weather. It's only bad clothing, which means you basically be prepared with your clothing and then get on with your experiment and work. That's what basically it means. So this building called the service building, this is how I saw it during the December trip, and this is how it looks during, I saw this during the last month trip. So very different from from the deep polar night to the present times where we are coming out of polar night. So this is a place where all the members of various countries in their respective research stations, they all assemble here for lunch, breakfast, and dinner. And then there's a conference room, and then there's a meeting room where meeting regularly take place every Wednesday. And then this is a picture of our during one of our I think lunch. And then there is a lot of facilities for laundry, and then various other high-speed internet connections, everything. So to make you make your life comfortable despite the harsh conditions. So because it's only a small community of people from various parts of the world working in isolated research stations, there is a lot of emphasis on cultural engagement in Nyanolsund. So there is this label on all dining tables. The table is for food and talk. So they don't encourage people to be looking at their mobile phones or laptops. So you need to talk with various people because anyway, already the conditions are isolated and challenging, so that everyone shares what experiment they're doing, and then about your culture and the conditions back home in the respective countries, and share knowledge and exchange what experiments each one is up to. So we participate in various activities. Like this is a picture from 2023. We were there during Christmas and New Year, and it's a culture where people from different research stations visit Himadri, India's research station, and then we go to, weekends we go to other stations. This is the Italy station, and then people engage themselves during weekends. They do a lot of knitting, and then drawing and painting, and then present them to their friends around the New Year time. In addition to this, national days of various stations, like for example, Himadri, if it is Republic Day, January 25th, January 26th, or Independence Day in August. So people from all of the stations gather in Himadri, and then there's coffee, tea served, and then people. So there's a sense of vibrancy about this place. And then June 2021st, International Yoga Day is also celebrated. People do yoga in their respective stations. So there's a lot of engagement to keep oneself busy and then in proper frame of mind in this remote challenging conditions. In addition to that, there's every opportunity for an active life to lead an active lifestyle. There is an indoor play area, there's a sauna, massage chair, there's a well-equipped gymnasium, and then people also go skiing. And then another very nice thing that these people do is there is this, you have access to these beautiful exotic cabins which are far away from the settlement. Typically you can carry firewood, food, and tea and biscuits and all these things, and then go away on a Friday evening and stay there till say Sunday evening or Monday morning, and then come back to work on Monday. And then this is you truly attempting to ski, but this picture is misleading. most of the time my legs were up in the sky, and then it basically means that I was repeatedly falling, and my skiing skills were pathetic. So this is the last slide, and then I would like to conclude saying that remote polar regions such as Arctic and Antarctic serve as the ultimate, albeit harsh, isolated, quiet laboratories of the planet Earth, providing radio silence needed to hear these faint signals from the most abundant element in the universe, while at the same time demanding extreme human adaptation, like like I tried to convey through various pictures and anecdotes, that we had to adjust ourselves to carry out these experiments. I think I'll conclude with this. I'll thank you all for your time and patience. Thanks for tuning in on a Sunday. I hope I had something interesting and useful for you to take home. Thank you.
Thank you very much, sir, for nice and excellent presentation and your experience in Arctic region.
Thank you, sir.
And if there are some questions, I think Dr. Kiran, yes, mute yourself and then ask, sir. Kiran?
Yes, sir. Yes, sir. Yes, sir. Sir, very nice presentation and very informative, sir.
Thank you, sir.
Sir, my query is, how massive was the first star compared to the modern star, sir?
I'm not really into astronomy or astrophysics of this. I'm not a cosmologist. I'm more focused on the engineering aspects of radio astronomy, building receivers. I'm sorry, I may not be in a position to answer this.
Yeah, if I may be permitted
Yes,
to
sir.
say
Yes, sir.
like
Yes,
a
sir.
line or
Yes,
two,
sir.
Girish, or
Yes, sir.
they're considered population 3 stars without metallicity. That's one point. But the other point, we have not been able to detect the stars or the black holes or whatever the structures are. So people are still not able to understand which are the first stars born in the universe and what is the possibility of their initial mass function. And depending on different initial mass functions, there are simulations explaining what are the different possible scenarios of the signal detection. But for that, still there is a lot of unanswered questions in that field, sir.
Okay. Thank you. Thank you, sir. Thank you.
Sir, yes, Keshav Murthy, sir.
Yeah, it's a nice experience that you presented.
Thank you.
I was, just wondering, what about, you are actually going to those remote places to avoid atmospheric interference, I believe.
Radio frequency interference, human-generated radio
But
frequency. Yes.
do not these solar flares and things like that, will they not also make it difficult for you for signal analysis?
Yes. So this is really a nice question. So SARIS experiment is observations are carried out during night, where we want to avoid the radio sun in our beam. So we don't want to, experiments are carried out during night times, say typically between 10 a.m. and say 10 p.m. and 5 a.m. In the night. So we were going there during polar winter, where you don't expect sun at all during this time of the year.
Oh, okay.
So we avoided that altogether.
Okay. So can you also comment on, some two more questions I have,
Yes.
simple questions, all layman's questions.
Yes, sir.
Why go with the terrestrial when you have space telescopes? That is one thing. And secondly, age of the signal, how do you determine? Is it by some variability analysis, something like Fermi variability and things like that? How do you do that?
Okay. So why do we carry out these things terrestrial, and then the experiments on Earth, and then why it is not? So there are a number of groups in the world which have proposed lunar and space missions for this to detect this faint 21 centimeter signals. So they're all yet to launch. China, Changi, it has tried to do that, but it has failed in its first attempt due to certain challenges they faced in terms of interference from self-generated interference. So right now, I don't think there is any mission which is being launched which is trying to detect these faint 21 centimeter signals. So the other question, maybe I would request Professor Uday Shankar to answer that.
Sir,
Shall I ask a question?
yeah, sir, Professor Kagli.
I'm sorry that I joined late.
Okay, sir.
I want to ask about the Himatri station you mentioned
Yes, sir.
being maintained by Indians.
Yes, sir.
What are the other activities going on there? Other type of experiments that are being carried out there? Could you
Yes.
give an idea about
Yes.
other experiments being carried out there?
Yes. So other experiments that are being conducted, there are climate change studies where people are trying to study atmospheric aerosols and contaminants and the climate implications over the Arctic. And then people say such experiments are very important because they have an effect on India's monsoons. So climate change studies is a major topic, and then one of the major considerations and concerns is the Arctic is warming up a factor of 2 or 3 faster than rest of the other parts of the planet. That is one major. So climate change is a major area. Climate change studies is a major area, and then people are trying to monitor Arctic clouds and precipitation. And other major area is electrical characteristics of the clouds. This person was trying to deploy his experiments and to carry the year-round recordings. They say that there are of late there are more lightnings and other activities over the Arctic, and then people are trying to study. So the broad areas and the more focus areas are climate change studies, atmospheric studies, and the next important thing that NCPWR and India is focused on is studying the marine life. I showed you a picture of the fjord there. This is the fjord. So people go to sample, to pick up marine samples, and those samples are brought back to India, and then they are studied. And then the changes in this marine environment is also an indication of warming up, and then loss of snow cover, all these things. So these are the major areas of research which is going on in Svalbard.
Thank you very much. Yeah.
Yes, Mallesh.
Sir, it was really a very nice talk.
Thank you, sir.
You were worried about so many interferences,
Right.
and somehow that interference occurred even during your speech. So, however, your signal was quite okay, right? What I mean is, there was some crosstalks when you were talking. I hope KPI will take care of this anyway. I have two questions. One is, there is hydrogen everywhere, and maybe Professor Keshamurthy asked this. How do you distinguish between the hydrogen of the past and hydrogen at present time? The 21 centimeter line can come from both of them, right?
Yes.
One,
Yes, sir.
maybe after you answer this, I will have, if time permits, another question.
Okay, I will try to answer from my limited knowledge of this. So the 21 centimeter from the local universe is at 1420 megahertz, whereas this 21 centimeter is the cosmological 21 centimeter from the cosmic dawn and epoch of reionization, which happened roughly about few hundred million years to 1 billion years. So because of the expansion of universe and the redshift which is undergone, the 1420 megahertz right now reaches Earth redshifted to a frequency range of 40 to 200 megahertz. That's how we distinguish between these two signals.
Oh, right. Thanks. My second question is, maybe Aditya is not the right satellite because it always looks at the sun. But there is another Lagrange point behind Earth which never sees the sun. My far-fetched idea is if somebody plans an experiment there, would it be nicer place there in that Lagrange point where it never sees the sun?
Maybe it is interesting, but and useful to do that. But that all these things are now again subject to the space authorities, and then giving you an opportunity to go to that place. From like what I want to tell you is there have been a couple of groups which have been trying to get a lunar mission for the past 20 years or so, something like that, for this cosmic dawn epoch of realization. And careers have been spent waiting for this, and it is really challenging to get even um, a Leo mission. Maybe these days it is slightly better. So it is well, it is possible. It is possible to do this, but it is subject to availability of slots and opportunity to reach there.
But let me thank you again for your excellent talk. Thank you, sir.
Thank you, sir.
Okay, sir. I think Sanjeev Gore, yeah, mute yourself and ask. I think one last question maybe. Okay.
Thank you, sir.
Sanjeev,
Actually, Sanjeev Go from ISRO. It was a nice presentation, Nagarajji. It is actually the comparison of the scale and all which you have taken, for example.
Okay.
Am I audible?
Yes, yes,
yeah,
please
yeah,
go on.
sir. Very nice.
Comparison of the scale which you have taken, one of the example, which shows that it reaches every student who is the beginner. I am basically electronics engineer. My question is about, uh, as you mentioned, the harsh weather conditions. What about the inside temperature of this your laboratory? Whether it is same as you tabulated or
Yes,
it
yes,
will
sir.
be maintained?
In fact, it's a very nice question. The very nice question. I'm very happy about it because you asked this question. Because that was a major problem for us. And then, especially during the polar night for the RF antenna installation, where I was alone on the trip and I had to repeatedly make trips from the one second, repeatedly move out from the laboratory below and then go to the terrace, that's a rooftop here, and then put in proper filters and other modules so that the band is clean. So I had to make a number of trips here. Like I mentioned, you dress up with multiple layers when you're outside to protect yourself, obviously. So the the temperature outside is roughly minus 18 degrees Celsius. Inside the lab here, it is maintained at plus 18. So just you take a modulus of the temperature. So what it does is, if you forget to remove the multiple layers, you'll start
Yeah, yeah.
heavily sweating inside, and then you will lose water in the
Yes, sir.
body.
One more last question. This, as the packages were very large in size, bigger in size,
Yes.
you were not able to take the package. Whether it mattered for the equipment, whether you're opening at the outside temperature and taking inside, whether they are tolerable for this extreme weathers.
Yes. So the choice of this is again a typical, very interesting question, which obviously comes from an electronics engineer who works with the for space developing space modules. I can really connect this question with you. The choice of components that we made for various modules or subsystems of the receiver, they were rated for minus 40 to plus 85. So
Very nice, sir.
we were not really concerned. We were, to that extent, we had taken care, and that was not a major concern. The the bigger challenge was of safety of the personal safety of the people there, and then it required a lot of convincing of Sarajit Singh, our station leader with the rifle there, saying that there's no other option but we have to do this outside. He was really not happy with this. But that's life. And then we're doing the first step. Obviously, he was not there, and then there's no way you can take this antenna inside the lab and then put it together and then carry it to the rooftop. It was all done alone. And I've just to let you know, it was very scary, and I was alone doing this at the entrance of the Grover's lab. So life goes on. You trust things. Someone will take care of you, and they do that.
Thank
But
you,
people
Girish,
don't have
and
this.
thank you for permitting my question.
Yes.
Basically,
thank
I
you,
am
sir.
electronics
Thank you.
engineer. Yeah.
Okay, in fact, for our viewers, we had a similar talk on November 2nd, 2025 from Jagadev Singh, IIA. In fact, he talked about first astronomical expedition to Antarctica region to study the sun at midnight. And
Okay.
today we have an experience with Girish about the Arctic. So we have covered from Antarctic to Arctic regions from both these scientists. In fact, you have given us very nice presentation, and in fact, you have explained all the queries. Thank you very much. From Karnataka Physics Association, we thank all the viewers who are our guests and also our KPA members. We thank from Karnataka Physics Association, Dr. M.K. Raghavendra, who is providing the Zoom platform, and Sai Venkatraman, who is providing the YouTube facility. In fact, even in YouTube, there are many students who are viewing this, and that is how Sai Venkatraman is making. Anyway, we have to thank you again, sir. You have accepted our invitation, and we have to thank Professor Uday Shankar also, because Professor Uday Shankar only has told us to contact you, and based on, of course, you have accepted and you have given a very nice presentation. Thank you again.
Thank
And
you.
we should
Thanks for the
thank
opportunity,
Professor
sir.
Pavli
Thank you very
also.
much.
I
Honored.
think he has joined, even though it was late. So thank you very much. If Professor Pavli has some announcement, I say please make it before we close down the.
Again, I wish to thank all the participants for joining the meeting, and would like to request them to join again next Sunday for another talk at the same time. Thank you all.
Thank you, sir. Thank you, one and all, for all those who have
I would like to
attended this session. Thank you.
Thanks a lot. So we can
I
close.
just would like to add, Professor Uday Shankar gave a very nice summary. Not
Yes, sir.
only introduced the speaker, but also his language and words are very, very encouraging. Thank you, sir.
With that purpose only, we asked him to give a talk, talk in the sense introduction, because we know that he used to say something other than the introduction also. That is why we have to thank him again.
I think the host.
It's my pleasure.
Yes, sir.
I'm a member of KPA, sir. It's my job.
Thank you, sir. Thank you.
Every member should do their job like you do.
And one more announcement, please. Anyway, during April 9th and 10th, we have a national conference at Reva University. It is organized by KPA and Reva University. Please join us for the conference, at least for the inaugural function. So thank you, sir. Please welcome.
One more thing, you please ask all the KPA members to register themselves to participate in the conference. So let us make it a very nice learning experience.
Yes, sir. Yes, sir.
All the KPA members should join, register themselves and join the meeting. I mean the conference during April 9th and 10th. It will be very interesting, covering a lot of topics, interesting topics. Thanks a lot.
Yes, sir.
Now the host,
Yes.
close the meeting. The host, who is the host, please close the meeting.
Yes, sir. Yes, sir. We will.
Thank you.